In Chapter 3, we'll be focusing on factors and products, and we're going to be building on some of the skills from grade 9, determining factors and multiples of whole numbers to 100, identifying prime and composite numbers, determining square roots of rational numbers, adding and subtracting polynomials, and multiplying and dividing polynomials. Our big ideas for this unit are arithmetic operations on polynomials based on arithmetic operations on integers and have similar properties, and multiplying and factoring are inverse processes. And we will look at factoring skills throughout this chapter. In section 3.1, we're going to deal with factors and multiples of whole numbers. Prime factorization is writing a natural number as a product of its prime factors. A second definition that we'll use in this section is a prime factor is a prime number that is a factor of a number, and a prime number is a number only divisible by 1 and itself. So again, keep these in mind as we move forward. A strategy for prime factorization is to build a factor tree. So if we wanted to do the prime factorization of 3,300, we could start by breaking that down into 33 times 100. And then 33 breaks down to 3 times 11. 100 could break down to 4 times 25. 3 and 11 are already prime. 4 would break down into 2 times 2, and 25 would break down into 5 times 5. So now if we were asked to list the prime factors of 3,300, they would be 2, 3, 5, and 11. And if we wanted the prime factorization of 3,300, it would be 2 times 2 times 3 times 5 times 5 times 11. Basically the product of all of these numbers down here. Now we could also write this as 2 squared times 3 times 5 squared times 11, and that also would be considered the prime factorization. So these two things would be considered the same. All right. Will every factor tree look exactly the same? No, there could be other ways that you could factor down 3,300, but no matter which way you start, you will always end up with the same prime factors and the same prime factorization at the end. All right, let's try our next example, and we want to write out the prime factors of 2646. So we want to do 2646, and one possible example or factorization would be 2 times 1323. The 2 obviously is prime. 1323 will break down to 3 times 441. So now I have 2 that's prime, 3 that's prime. 441 breaks down into 3 times 147. And now 147 breaks down into 3 times 49, and we're getting very close. 49 breaks down into 7 times 7. So again, if we want to write out the prime factorization, it would be 2 times 3 cubed, because there are 3 of those, and then we would multiply it by 7 squared, and this would be my prime factorization. Obviously, the prime factors would be 2, 3, and 7. Okay, we're going to use our skill of factoring and factor trees to help us find greatest common factors. Okay, so a greatest common factor is the greatest factor 2 or more numbers have in common, and we often refer to this as our GCF. Determine the greatest common factor of 138 and 198. Well, the way we do this is we're going to make a factor tree for each of these. Okay, we'll do 138 first. 138 breaks down into 2 times 69, and 2 is prime. 69 breaks down into 3 times 23. 189, it breaks down into 2 times 99, which breaks down into 9 times 11, and 9 is 3 times 3, and we have our 11. So now, to find the greatest common factor, here is what we do. Once we've got our prime factorization for both numbers, we take whatever is common to both. So there's a 2 here, and there's a 2 here. So I'm going to write a 2 down here. And we have a 3 here and a 3 here. That means I'm going to multiply that by a 3, and that's all that's common. So 2 times 3 is 6. So that means the greatest common factor for 138 and 198 would be 6. All right, let's take a look at the next example. So I'd like you to pause the video and give this one a whirl on your own. Well, hopefully you've had a chance to try this one. And let's take a look. We want to do 144 and 126. I'm just going to get some more room here. So I have 144, and the other factor was 126. So if we break down 144, it breaks down into 2 times 72. 72 can be broken down into 2 times 36. 36 can be broken down into 6 times 6. And 6 is 2 times 3, and 2 times 3. So there's your prime factorization of 144. For 126, it's going to be 2 times 63. And 63 is 9 times 7. And 9 breaks down into 3 times 3. So now, to identify the greatest common factor, I'm going to indicate what's common. So I have a 2 here and a 2 here. So that means I can put 1, 2 down there. I have a 3 and a 3 and another 3 and another 3. So that means I can put 2 3s down here. And therefore, the greatest common factor is 2 times 3 times 3, which is going to be 18. So that is how we use our prime factorization to help us find greatest common factors. Okay? All right. Now we have 3 numbers now. We want to find the greatest common factor of these 3. So let's go through the same process. So we're going to start with, we have 120. Our next number was 960. And our third number is 1400. Now I'll try to squeeze all these prime factors into this page. So 120 is 2 times 60. 60 can be broken down into 4 times 15. And 4 is 2 times 2. And 15 is 3 times 5. So there are the prime factors of 120. 960 is going to break down into 10 times 9. Actually, I'm going to move 960 over a little bit just so that I can maybe squeeze it in a bit better. So it's going to break down into 10 times 96. And 10 is 2 times 5. 96 is 6 times 16. 6 obviously is 2 times 3. And 16 can be 4 times 4. Finally, 2, 5, 2, 3, 2 and a 2, and another 2 and a 2. So there's the prime factorization of 960. And for 1400, we're going to break that down into 14 times 100. 14 is 2 times 7. And 100 is 10 times 10. Again, this is going to break down into 2 and 5, and 2 and 5. This is a 7. All right, so now to find the greatest common factor, I'll get another color here. Let's use a purple. Find the greatest common factor. We are looking for things that are common. So I have a 1, 2 here, a 2 here, and a 2 here. So I can put a 2 down there. I have another 2, another 2, and another 2. So I can put another 2 down there. And I have a third 2 common to all three. So I can actually have 3 2s. And if I look at the other prime factors, the only one that's common is a 5. I'm going to add a 5. So 2 times 2 times 2 times 5 is going to give me a common factor of 40. All right. Finally, another application, if you want to think of a prime factorization, is going to be when we're reducing fractions. Now, some of our calculators will automatically reduce these now, but you could use your prime factorization skills to do this. So if we made a factor tree for 650, and I'll let you do that on your own, but if you did do a factor tree for 650, the prime factorization would be 2 times 5 times 5 times 13. And if you did one for 900, it would be 2 times 2 times 3 times 3 times 5 times 5. And now what we would do is we would just cancel out anything that's common. This 2 cancels out that 5 cancels out that 5 cancels out that 5. And then we multiply any term that's left in the numerator. So I just have a 13 left. 2 times 3 is going to be 18. So 13 over 18 is the reduced fraction of 650 over 900. Okay, I'm going to encourage you to pause the video quickly and try to do the next one on your own. Okay, I'm hoping you had a chance to try that. So if we take a look at the prime factors of 1225, it's going to be 5 times 5 times 7 times 7. And if we look at the prime factors of 2720, it's going to be 2 times 2 times 2 times 2 times 2 times 5 times 17. So again, if we do our canceling, the only thing that cancels is 1 5 cancels out with one of those 5s. And 5 times 7 is 245. And in the bottom, 32 times 17 is 544. And that would be the reduced fraction of 1225 over 2720. Okay, so there is the end of the first lesson. I'll just get rid of these old notes here from before. And your assignment for this section is on page 139. So you can give that a try, and you can look at the answers on the website if you're having some problems.